that feeling, right? Staring at a blank screen, maybe a mountain of work ahead, and just wishing a magic wand could just, poof, get it done.
Happens to the best of us.
Or maybe it's all the chatter about AI taking over jobs, especially in fields that seem so, well, fundamentally human, like writing code.
Yeah, that buzz is everywhere.
Well, in the world of software development, that magic wand isn't just a fantasy anymore. It's becoming a very real, very powerful presence, AI. But what does that really mean for the people behind the code? The architects, the builders of our digital world.
That's the million-dollar question, isn't it?
Today, we're taking a deep dive into exactly that. A question sparking, well, intense debate everywhere. Tech companies, universities, probably even your dinner table. Will AI replace coders?
A big one.
We're going to look at how AI, from these sophisticated, almost everyday assistants like GitHub Copilot,
Which so many people use now.
exactly, to these really ambitious new contenders,
Yeah.
marketing themselves as full-fledged software engineers, like Devin.
Yeah, Devin's made some waves.
We want to see how it's truly impacting the craft of coding.
Yeah.
We're trying to get beyond the headlines, cut through the hype.
Separate the signal from the noise.
Right, to really understand the truth about this whole augmentation versus replacement thing. What's actually happening on the ground for developers like you?
And our mission for you in this deep dive is, well, it's to equip you with a truly clear, grounded understanding.
Yeah, cut through the fiction.
Exactly. Separate the fact from the, let's be honest, often overblown fiction. We'll take a journey, starting way back with the historical roots of automatic programming.
Which goes back further than you might think, right?
Oh, absolutely. You might be surprised how old this dream actually is.
Yeah.
Then we'll look at the psychological impacts these tools are having. It's profound.
Yeah, how people feel about using them.
And how it changes how they work. We'll unpack the latest AI coding tools, look at their real-world performance, not just the demos.
The good, the bad, and the ugly.
Pretty much. And we'll even delve into the global policies, the regulations that are rapidly shaping this whole new frontier.
Because governments are definitely paying attention now.
They are. The goal is you'll walk away not just informed, but with a nuanced, actionable perspective. You'll understand what this means for the future of work, for innovation, maybe for your own career.
So you can navigate it, not just react.
Precisely. We want you to feel confident in navigating these complex layers, prepared for what's coming.
And trust me, we'll be uncovering some genuinely surprising facts along the way.
Oh, yeah.
For instance, did you know that in certain situations, AI can actually, get this, slow down experienced developers?
Counterintuitive.
Right. Or that some of its biggest security pitfalls lie in areas you might, well, least expect. Get ready for some serious aha moments.
I'm ready.
These might fundamentally reshape how you think about AI and coding. The reality, as we'll soon discover, it isn't a simple yes or no. It's much more intricate. It's a recomposition of roles, responsibilities, the very nature of building software. So let's unpack this.
Let's do it. And to really grasp where we are today, we first have to appreciate that this dream, the dream of machines writing their own code, it's not new.
Right, you said it goes way back.
Way back. It's a goal that stretches back to the very dawn of artificial intelligence itself, that iconic Dartmouth workshop in 1956.
The birthplace of AI, basically.
Widely seen as that, yes. And right from that moment, a huge ambition was creating systems that could automate programming. Think about pioneers like John McCarthy, who developed LISP.
A foundational language.
Absolutely. His work and early program synthesis research by visionaries like Zohar Manna and Richard Waldinger back in 1971, they explicitly imagined systems that could derive programs directly from high-level specifications.
So like you just tell the computer what you want.
Exactly. You describe the goal, I want a program that does X, and the machine would figure out how to write the code to achieve it.
So even back in the 50s, the 70s, this wasn't just, science fiction on TV.
No, it was serious academic research. People were genuinely trying to tell a computer, hey, write me a program that sorts these numbers, and have it spit out the code.
But obviously that didn't happen overnight. What were the big roadblocks back then? What kept this dream just a dream for so long?
Excellent question. And it really highlights the massive gap between that ambition and the technical reality of the time.
Yeah.
The biggest limitation, well, it was raw computational power, of course, just minuscule compared to today.
Can't even imagine.
But maybe even more critically, the approaches to AI were very different. They were symbolic, rule-based, meaning researchers tried to literally encode human programming logic into explicit rules. Like, if the input is this, then do that.
Okay.
And that worked okay for very narrow, very well-defined problems. But programming, even simple stuff, gets incredibly complex, incredibly context-dependent, really fast.
Right, the edge cases pile up.
Exactly. The sheer number of rules and exceptions just became unmanageable. There wasn't a scalable way for these early systems to, learn and adapt from lots of existing code.
Because there wasn't much code easily available.
Well, that big code didn't exist in accessible formats, not like today. And fundamentally, the learning algorithms just weren't there. It was like, imagine trying to teach a kid to write a novel by just giving them a dictionary and a grammar textbook.
Without letting them read any actual book.
Precisely. The underlying paradigm for learning from examples, from data, was essentially missing.
That's a great analogy.
Yeah.
Okay, so let's fast forward a bit then. That dream, it started to feel maybe a little more tangible, not through pure AI taking over, but through tools that helped us.
Yeah, assisted, yeah.
By the 1990s, software was everywhere. It was becoming foundational. And these things called integrated development environments, IDEs, really started taking off.
Your Visual Studios, your Eclipses.
Exactly. And this era brought us something huge. An innovation many developers now just completely take for granted, IntelliSense-style code completion.
Ah, yes. Autocomplete for code.
Basically. If you've ever typed, object in your editor and had that neat list of possible methods or properties pop up, that's IntelliSense. Or something like it.
Life-saving sometimes.
It was a total game changer back in the mid to late 90s. Before that, you literally had to remember every single function name, the parameter order, everything.
Yeah, lots of trips to the documentation or keeping huge manuals on your desk.
Totally. It was all pure recall, which meant frustrating typos, constant lookup.
It slowed you down.
Hugely. IntelliSense fundamentally shifted that labor from pure recall to recognition. You saw suggestions, you picked one.
Makes sense.
It made coding faster, way less error-prone, and frankly, just less mentally exhausting. It was a massive cognitive shift.
Reducing the load.
Yeah. Instead of constantly digging through your mental database or external docs, you were suddenly guided. It felt more fluid, more efficient, and crucially, it started to train developers to expect smart suggestions, to rely on them.
Paving the way.
Exactly. Paving the way for what we're seeing today with much smarter AI assistants.
Absolutely. IntelliSense was that crucial bridge. It showed the power of intelligently assisting the developer without trying to replace them completely. But the real leap, the technological jump that allowed modern AI coding tools to go beyond simple matching to generating, complex, context-aware code, that came in the 2010s.
Okay, what happened then?
This was powered by what we call statistical code, and the foundation wasn't just faster chips. It was two really key developments. First, the rise of big code.
Right, you mentioned that. All the code online.
Essentially, yeah. These vast publicly available repositories, GitHub, Stack Overflow, open source projects everywhere, just billions and billions of lines of code. That became the training data.
The textbook, finally.
Kind of, yeah. The library the AI could read. Second, huge advancements in deep learning models, particularly neural networks. They provided the computational architecture that could actually process these enormous data sets.
Got it. So statistical code. What does that mean exactly? Does it understand the code?
Not really in a human sense. These models learn the grammar, the syntax, the idioms of code, but through statistical probabilities. They don't understand the meaning, the semantics, but they become incredibly good at predicting the next most likely word or token in a sequence.
Like predictive text on your phone, but for code?
Exactly like that, but way more powerful. On steroids, as you said earlier, they learn from seeing billions of lines of existing code. They spot incredibly complex, subtle patterns that humans might miss.
Okay, so that's the underlying tech. Was there a breakthrough moment?
There was. Many people point to OpenAI Codex in 2021 as truly pivotal. This was a model that could actually turn natural language descriptions, plain English, into working code snippets.
Wow. So you could just describe what you wanted?
Pretty much. It bridged that gap between human intent and machine instructions in a way we hadn't seen before. And this powerful tech was then harnessed by GitHub Copilot.
And that's when it really hit the mainstream.
That launched the first really widespread wave of AI coding assistants, putting this power directly into the hands of millions of developers worldwide. It wasn't just suggesting the next word. It could generate entire functions, classes, even small programs, just based on a comment or a description.
That's a massive leap. Which brings us right up to now, 2024, 2025, where it feels like we're moving super fast again, moving from just suggestions to AI tools that claim to, well, do a lot more of the work.
The pace is definitely accelerating.
GitHub Copilot, for instance, it's not just the basic autocomplete anymore, right? It's matured dramatically.
Yeah, it's a whole suite now.
You've got Copilot Chat, where you can literally talk to the AI in your editor, ask questions, get to refine code.
Like having a conversation about the code.
Exactly. Then there's Copilot Enterprise, which aims to integrate AI across a whole company's code base. And even Copilot Workspace, which is designed to understand entire repositories, generate tests, fix bugs, and this is the big one, even plan changes directly from a high-level issue description.
From the ticket itself.
Right, so it's not just lines of code, it's trying to handle the whole task lifecycle. It's becoming this deeply integrated assistant.
A much bigger scope.
But then you have something even more ambitious that's been grabbing headlines. Devin, by Cognition Labs.
Ah, yes, the AI software engineer.
That's how they market it. Bold claim.
Yep.
Devin supposedly can autonomously read an issue from, say, Jira, browse the web for documentation if needed, write the code, run it, debug its own errors,
The debugging part is interesting.
and then even submit a pull request.
Yeah.
All on its own, apparently with minimal human input.
Supposedly.
And it showed some really impressive results on SWE-bench, which I hear is a notoriously difficult bug-fixing benchmark.
Yeah.
That indicates a pretty significant leap in autonomous task completion, if true.
And that's precisely where the conversation really shifts, doesn't it? When an AI isn't just suggesting code, but it's planning, executing multi-step tasks, even fixing its own mistakes.
Yeah, that definitely cranks up the heat on the will it replace me question.
It absolutely does. But, and this is a huge but, we need to add a significant caveat here, one that often gets drowned out by the hype.
So what's the catch?
Access to Devin is still extremely limited, and the public demos we've seen, they've been very highly curated, carefully edited to showcase success.
Ah, the highlight reel.
Exactly. And this has, quite rightly, sparked a lot of debate and scrutiny in the developer community. While the benchmark results are impressive on paper,
Benchmarks aren't always the real world.
not even close sometimes. Benchmarks are often, by their nature, highly contained, sanitized environments. They're worlds away from the messy, interdependent, often poorly documented realities of actual enterprise software development.
Yeah, the spaghetti code no one understands anymore.
Precisely. We've seen these cycles of AI hype before, right? The gap between performance in a controlled lab setting and reliable deployment in the wild can be absolutely vast.
So manage expectations.
Definitely. It's a powerful indicator of potential, sure. But we have to approach these AI engineer claims with a very healthy dose of skepticism and demand transparent, real-world validation, not just slick demos.
That's such a critical point. It is easy to get swept up in the vision, but yeah, the real world always has other plans. And these claims, whether they pan out fully or not, they certainly stir up a lot of feelings.
Understandable.
Which leads us right into the psychological and sociological ripples these tools are creating within the developer community itself.
Yeah, the human element.
When we talk about AI entering any workspace, there's always that inherent tension, isn't there? The classic deep-seated fear of job automation.
Will the robots take my job?
Right. Versus the hope, the promise of significant human augmentation.
Making us better, faster, stronger.
And the emergence of these AI coding tools, especially things calling themselves engineers, it just reignites those long-standing automation fears. It triggers that really primal concern. Is my job next? Am I going to be obsolete?
It's a completely natural, visceral reaction. You see something that appears to do what you do, and that's threatening.
Yeah.
However, what we're actually seeing in real-world experience, day-to-day use, it often aligns much more closely with a kind of pair programmer reality.
Okay, what does that look like?
It looks like the AI genuinely augmenting human capabilities rather than replacing them outright. Developers often describe their AI assistants, like Copilot, as a highly capable, sometimes maybe a bit error-prone, but generally helpful junior partner.
Like an intern who's super fast but needs supervision.
Kind of, yeah. Controlled studies have consistently shown perceived speed-ups and, interestingly, higher developer satisfaction among those using these tools. especially for the boring, repetitive tasks.
Getting rid of the drudgery.
Exactly. And this is absolutely crucial. The human consistently remains in charge. They're the ones policing the quality, ensuring correctness, catching the subtle errors, applying the context.
The final sign-off is human.
Always. And this pattern mirrors what we've seen in other knowledge-heavy fields. It's often called the centaur pattern.
Like the mythical creature.
Precisely. A powerful collaboration where humans and AI work together, each leveraging their unique strengths. Think of it like a chess grandmaster working with a powerful chess AI.
Okay.
The human brings the intuition, the strategic understanding, the long-term vision, the creativity. The AI handles the brute force calculation, the pattern recognition across vast possibilities, the instant recall.
So it's not just about raw speed.
Not at all. It's about expanding the human's capacity for complex thought by offloading the routine, the mentally taxing but less creative parts of the job.
That centaur idea is really compelling. It definitely addresses that initial fear head on, but I mean, it almost sounds a little too perfect, doesn't it? Where do most teams or individual developers typically struggle to actually achieve that perfect synergy? Is it a training thing? A trust thing? What's the friction?
That's a brilliant observation, because you're right, achieving that seamless centaur state isn't trivial. It doesn't just happen.
Yeah.
One major struggle is simply learning how to talk to the AI effectively, prompting. It's a genuinely new skill, a new kind of literacy.
Right, you can't just bark orders like at a compiler.
Exactly. Developers used to giving very explicit instructions now need to learn to be, well, conversational, but also very specific with a generative model. It's almost like training a junior engineer who sometimes misses the implied context or the bigger picture.
So there's a learning curve to the prompting itself.
A significant one. You have to learn the AI's personality almost. Its strengths, its weaknesses, its common ways of messing up.
And then there's trust, you mentioned.
Yeah. Yes, or rather the calibration of trust. Overtrusting, as we'll get into, can lead straight to security holes or just bad code.
Yep.
But undertrusting means you ignore potentially valuable suggestions, you lose efficiency, you basically negate the benefit. Finding that sweet spot where you critically review but don't just rewrite everything the AI does that takes practice and experience.
So it's a balancing act.
Definitely. And finally, just the practical integration into existing workflows can be clunky. Not all tools play nicely together. Sometimes the AI suggestions just don't fit the team's established coding style or architectural patterns, leading to more manual cleanup and frustration.
Right, it might generate technically correct code that just doesn't fit here.
Exactly. So while the potential is absolutely immense, it requires a conscious effort from developers and teams to adapt, to build new habits, new review processes.
That's a fantastic breakdown of the practical hurdles, and it makes me think about how these tools change us, not just the code we write. You know, like the chess player example, partnering with AI forces them to think differently.
It reshapes their own process.
So let's dig into that. What are these AI coding tools actually doing to our minds as developers? The cognitive effects.
Yeah, this is fascinating.
First, there's the idea of flow and fatigue. I think every coder listening right now has a horror story, right? Spending a whole afternoon just getting a build environment set up correctly.
Oh, yeah. Or wrestling with config files.
Or just slogging through endless boilerplate code for a new feature. It's often called yak shaving, these tedious, repetitive setup tasks that pull you away from the actual creative problem solving.
The stuff that drains your brain power before you even get to the real work.
Exactly. And tools like Copilot can significantly reduce this yak shaving. They can generate initial structures, boilerplate, maybe repetitive test cases.
Taking that off your plate.
Right. By offloading these mundane, mentally draining parts, the idea is that AI allows developers to stay in that deeper state of flow, you know, where you're intensely engaged in the creative problem solving without constant interruption from grunt work.
Maintaining focus.
Yeah. Which not only conserves precious mental energy, but should also lead to higher job satisfaction. Imagine jumping straight into the interesting logic puzzle instead of spending hours setting up database connections or basic API endpoints.
That sounds pretty good.
That's not just faster, it feels genuinely more satisfying, right? Less likely to lead to burnout.
Absolutely. That benefit to developer well-being, their actual enjoyment of the work, it often gets lost when we only talk about productivity metrics like lines of code.
Yeah, it's quality of life too.
But there's a pretty significant flip side to all this convenience, a real danger. Overtrust and the potential for skill decay.
Okay, this sounds serious.
It is. Early security studies revealed a truly alarming finding. Approximately 40% for 0% of code generated for risk-prone tasks.
Like what kind of tasks?
Things like cryptographic implementations, handling authentication, input validation, secure data storage. Critical stuff.
Got it.
Around 40% of AI-generated code for those tasks contained insecure patterns if it wasn't properly reviewed by a knowledgeable human.
40%, that's huge.
It's staggering. Think about it. An AI might generate a function that looks right for, say, hashing passwords, but maybe it uses an old, weak algorithm like MD5, or it stores the salts improperly. That leads directly to a common weakness enumeration, a CWE class vulnerability, like making you vulnerable to brute force attacks or rainbow table attacks.
Things you definitely don't want.
Exactly. Or improper neutralization of special elements leading to injection attacks. This highlights a really serious over-reliance trap.
Especially for less experienced developers.
Particularly for them, yes. They might implicitly trust the AI's suggestion without having that deep understanding of the underlying security implications or the specific context of the system they're building.
Because it looks plausible, and maybe it even works in basic tests.
Right. For a junior developer, maybe rushing to meet a deadline, seeing an AI suggestion that seems to work and passes the simple tests, it's incredibly tempting to just accept it and move on.
Yeah, I can see that pressure.
But what they might miss, and what the AI often doesn't grasp, is a subtle timing attack vulnerability. Or maybe a lack of input validation that opens the door to cross-site scripting, XSS. These aren't obvious errors sometimes.
So the convenience is a trap if you're not careful.
It's a powerful tool, absolutely. But it becomes a double-edged sword if you let your guard down, especially when dealing with sensitive, security-critical parts of your application. Vigilance is key.
Wow, okay, that 40% figure is genuinely shocking. And the over-reliance idea. Yeah, that's something everyone using these tools needs to take incredibly seriously. It's not just a tool, it's a new layer of risk management.
Well put.
But here's where it gets really interesting for me. A true aha moment, potentially for many listeners. And it relates to experienced developers. Expert dissonance.
Ah, the METR study.
Exactly. A 2025 METR study looked at the actual impact of AI on developer productivity, and it showed something completely counterintuitive. Experienced developers working with AI were actually about 19–20% slower on familiar code repositories compared to when they didn't use AI.
Slower.
Not faster.
Slower. It totally challenges the common assumption that AI always makes things faster for everyone.
So why? What was slowing them down?
The study found time was lost due to several things. First, carefully crafting the prompts to get the AI to understand the specific context of this familiar, complex code base.
Right, explaining it to the AI takes time.
Then, meticulously reviewing the AI's suggestions for correctness, for style consistency, for those subtle errors an expert would spot.
The verification overhead.
Exactly. And also just the inherent latency, waiting for the AI to generate the output. But here's the real kicker.
Go on.
Despite being objectively, measurably slower, these same experienced developers believe they were faster when using the AI.
Whoa. So their perception didn't match reality.
Not at all. Which points to the critical importance of what we might call calibration skills, understanding precisely when and how AI truly adds value versus when it actually introduces overhead and slows you down.
Knowing when not to use the tool. Exactly. For an expert who already knows the code base inside out, who can often just write the correct idiomatic code faster than they could explain the requirement to an AI and then rigorously review its attempt,
Yeah.
the AI can become an impediment.
Like having to explain every step to an apprentice when you could just do it yourself.
Perfect analogy. It's like an expert chef being asked to supervise a junior sous chef for every single tiny chop and slice. The supervision itself can slow them down significantly, even if they perceive the junior chef as helping overall.
That finding on expert dissonance is absolutely crucial. It really forces us to look beyond just raw speed as the only metric.
Yeah.
It shows how easily our perception can be swayed by new tech.
Yeah, the novelty factor, maybe?
Perhaps. We have to critically reevaluate assumptions about AI's universal benefits. It's not a magic bullet for every task, for every person.
Makes sense.
And beyond these individual cognitive effects, AI is also fundamentally reshaping how teams work together. The social dynamics, the collaboration patterns.
How so?
Well, for one, it's normalizing a new form of asynchronous pair programming.
Asynchronous. So, not real time.
Right. The AI acts as this constant, always available partner you can interact with whenever you need it. In this model, the AI can efficiently draft the boilerplate, generate initial tests, maybe handle some routine data transformations.
Report work again.
Exactly, which allows the human developers to focus their limited mental energy on the higher level responsibilities. Things like architectural design, complex problem decomposition, breaking down big challenges, and critically, navigating the ethical considerations or the broader business context. Stuff the AI just cannot grasp.
So a clearer division of labor based on strengths.
Precisely. It optimizes the unique strengths of both human and machine, letting humans operate at a higher level of abstraction, focusing on the truly hard problem.
Okay, that makes sense. What else is changing in teams?
This deep integration of AI is also introducing entirely new team practices, new rituals into the software development lifecycle.
Like what kind of rituals?
For instance, we're seeing the emergence of prompt reviews. Teams will actually sit down and critically examine and refine the instructions, the prompts they're giving to their AI.
Reviewing the questions, not just the answers.
Exactly. To ensure clarity, specificity, maybe adherence to internal standards. Teams might share effective prompts, critique ones that led to bad results, maybe even build internal libraries of good prompts for common tasks.
Interesting, like a new form of code standard, but for prompts.
Kind of. Then there are AI diff reviews, which are distinct from your standard code review. These specifically look at changes proposed or generated by AI.
How are they different?
They focus not just on correctness and style, but also on looking for those subtle inconsistencies, potential security flaws we talked about, or maybe deviations from the intended architecture that an AI might introduce without realizing it. Reviewers might be specifically looking for common AI hallucinations or typical error patterns.
So knowing the AI's weaknesses helps the review.
Definitely. And perhaps most importantly, teams are developing guardrail checklists. These are meant to ensure that AI outputs consistently meet established quality, security, and compliance standards before they even get merged into the main code base.
Like a pre-flight check for AI code.
Exactly. So you see, it's not just about a single coder anymore. Entire team dynamics are shifting, evolving. It's fostering a new kind of collective intelligence, really, that integrates human oversight deeply with machine generation.
It's incredible how quickly these tools have gone from, niche experiments to just essential parts of the workflow.
The adoption has been rapid.
Which brings us to the mainstream impact and, importantly, global governance. Because AI's footprint in development today is huge, it's everywhere. And the regulators, the governments, they're definitely starting to take notice.
They have to.
Adoption is mainstream. There's really no doubt about it. GitHub themselves, numerous industry surveys, they all confirm this rapid uptake of AI coding tools. Small startups, giant enterprises, everyone's using them.
It's hard to find teams that aren't at least experimenting.
Right. And GitHub Copilot, in particular, is frequently cited as the most used tool among engineering teams. It's almost becoming an expected part of the modern developer's toolkit, like having a good IDE or version control.
Table stakes, almost.
Pretty much. But it's rarely just one tool anymore, is it?
No, we're seeing stacks emerge.
Yeah, it's becoming really common for developers to use a stack of multiple AI tools, each maybe specializing in slightly different areas or integrating better with certain platforms.
Like using Copilot generally, but maybe Gemini Code Assist if you're deep in Google Cloud.
Exactly. Or Amazon Q for AWS-focused stuff.
Yeah.
Or maybe something like Cursor, which is like an AI native code editor. Developers are picking the best tool for the job or the one that fits their ecosystem best.
Optimizing their AI toolkit.
Yeah. So it's absolutely not an experimental niche anymore. AI coding is now a standard, often indispensable part of the developer's toolkit. The question really isn't if you're using AI, it's more how effectively are you using it and which tools fit your needs best.
And when we try to measure the impact of all this widespread adoption, it's what's a nuanced picture. You have to balance the speed gains against the quality implications.
Right, it's not just about going faster.
Exactly. GitHub run experiments and several follow-up studies have pretty consistently observed that roughly 55% faster completion time on certain types of tasks.
That's a big number. What kind of tasks?
Particularly that highly repetitive boilerplate generation we keep talking about. Setting up the basic structure for a new web server, for instance. That's a genuinely significant gain, especially when starting new projects or adding standard features.
So it speeds up the initial setup dramatically.
It can, yes. However, other independent studies, looking at the entire development lifecycle, show more mixed effects on overall code quality and final delivery speed.
Ah, so the benefit isn't always uniform.
Not always. The general consensus seems to be you see strong, consistent gains on boilerplate tasks, and also during the initial exploration phase of a project.
Like when you're just trying things out.
Yeah, scaffolding a new microservice, setting up a basic database schema, getting a simple API endpoint working. Tasks where the AI can quickly generate a plausible starting point from a simple description.
Okay, so good for getting started. Where does it struggle?
Where AI shows weaker performance and where that human oversight remains absolutely paramount is on the really intricate stuff. Legacy code bases or highly security critical work.
Gnarly problems.
Exactly. Trying to understand years of accumulated technical debt. Debugging subtle, intermittent bugs that only happen under load. Writing rock-solid cryptographic components. The AI's lack of deep contextual understanding means it often struggles there, or worse, gives plausible but wrong answers.
So the takeaway is?
If you're starting a new project, greenfield. AI can give you a massive head start. But for those deep, complex problems in existing systems where you need architectural understanding, intuition, knowledge of hidden dependencies, you still absolutely need that human touch, that deep understanding of context, implications. The AI is a tool, not a replacement for that deep expertise.
And beyond the code itself, these powerful tools are attracting some serious attention from regulators, right? Shaping the global policy, the governance landscape, really quickly.
Yeah, the legal and ethical frameworks are trying to catch up.
Our governments worldwide are grappling with this. How do we ensure these incredibly powerful AI systems are developed and used responsibly? Take the EU AI Act, for instance. That's a landmark piece of legislation.
Huge implications.
And now it directly applies to what they call general purpose AI, GPAI systems, which definitely includes coding assistants like Copilot, like Devin.
No ambiguity there.
No. The implementation is phased, but the obligations for the GPAI providers start kicking in around August 2025, with broader rules hitting in August 2026, 2027.
So, fairly soon,
Right.
What does it require?
It places significant pressure on the providers, the companies making these tools. They need to transparently document their training data, like where did it come from, what's in it. They need to manage copyright compliance. They need to conduct really rigorous risk assessments for potential biases, security flaws, societal impacts.
That's a massive compliance burden.
Huge. And then if you look over at China, they introduced their own interim measures back in August 2023.
A different approach.
Somewhat, yeah. Their measures have a really strong focus on provenance, knowing the origin of the data used for training and generation, but also a heavy emphasis on safety and, importantly, state-aligned governance at the platform level.
More top-down control.
It signals a distinct governance style compared to the EU's risk-based approach. More emphasis on content control and national interests. What's really fascinating here is that this whole conversation, it's clearly not just technical anymore.
No, it's legal, ethical, even geopolitical.
Governments are stepping in, setting rules to ensure these powerful tools are built and used responsibly. And that has real, tangible implications for how tech companies operate globally, how these AI systems are designed, deployed, and ultimately how developers use them.
It absolutely broadens the scope of responsibility, not just for the AI vendors, but for the organizations deploying these tools in their workflows too.
Yeah, everyone's involved.
And with all this attention, both the excitement and the caution, it's just vital that we dispel some of the most common myths that are swirling around about AI in coding.
Good idea. Let's tackle the myths. Where should we start?
Let's start with the big one, the one that causes the most anxiety. AI will replace coders outright.
The extinction event for developers.
Pretty much how it's sometimes framed, but this is largely a myth, at least for the foreseeable future.
Why do you say that? What's the evidence?
Well, as we've discussed, the real-world studies consistently show that developer productivity doesn't just go up with AI, it can swing up or down.
Depending on the task, the person.
Exactly. Depending on the specific task type, the developer's own expertise, how well the tool actually fits into their established workflow. The evidence simply doesn't point towards elimination. What it does point towards is a recomposition of the coding job.
Recomposition, meaning the job changes but doesn't disappear.
Precisely. The nature of the work is changing. It's shifting away from the more repetitive, lower-level tasks like typing up boilerplate or simple functions.
The stuff AI is good at.
Right. And it's shifting towards higher-order thinking, architectural design, complex problem decomposition, critical review and validation, human AI orchestration.
More strategic work.
Exactly. So instead of this sudden mass displacement event that some headlines scream about, what we're actually witnessing is more of a gradual but, yeah, profound transformation.
So the job evolves.
The job evolves. New skills become crucial: prompt engineering, AI integration, critical assessment of AI output. But the human remains absolutely at the core of the creative process, the strategic decisions, and ultimately the responsibility for the final product.
So AI isn't replacing the conductor of the orchestra.
It might be replacing some of the instruments or maybe providing a really fast sheet music writer,
Yeah.
but the human is still very much writing the symphony, leading the performance.
That's a crucial distinction, and frankly, a reassuring one for many people listening, Ahmed. It sounds like it's about adapting skills, not ending careers.
That's how the current evidence points.
Okay. But speaking of risks, another really dangerous misconception we need to tackle head on is the myth that, Copilot code is always safe. Or code from any AI assistant, really.
Oh, that's a critical one. And yes, it's unequivocally false. Believing that is potentially catastrophic.
Why is it so dangerous?
Because, as we touched on with that 40% figure, without diligent, expert human review, AI suggestions, particularly for critical functions, can absolutely embed serious security vulnerabilities, those CWE class flaws.
Could you give a couple more concrete examples? How might that actually happen?
Sure, an AI might suggest code for handling user input, maybe in a web form, but if that code doesn't properly sanitize the input, it could be vulnerable to SQL injection.
Allowing an attacker to mess with your database.
Exactly. Or it might generate an authentication routine that, say, uses an insecure hashing algorithm for passwords, or maybe it leaks information through error messages, or doesn't handle session management securely, opening the door for account takeovers.
And these aren't just theoretical.
Not at all. These are very real, documented risks found in AI-generated code and studies. Now, things like secure by default, prompting explicitly asking the AI, generate a secure version of this function using prepared statement.
Telling it to be secure.
Right,
Yeah.
that helps. And automated code scanners, SAS tools, they can certainly help catch some of these flaws. But they do not fully eliminate the risk,
Why not?
because context matters immensely in security. A piece of code might look secure in isolation, but create a vulnerability when combined with other parts of the system. AI often lacks that holistic, system-level understanding. And scanners aren't perfect either. They miss things, especially novel or complex vulnerabilities.
So back to the junior developer analogy.
Exactly. Think of it like getting suggestions from a well-meaning but sometimes naive junior dev. They might offer a quick solution that seems to work on the surface, but you still need that experienced eye, that senior developer mindset, to catch the potential security flaws, the architectural missteps, the subtle issues that the AI, lacking true context and threat modeling capabilities, might not grasp.
So that human layer of critical security review is just non-negotiable.
Absolutely non-negotiable, especially for anything sensitive. That human oversight is the ultimate firewall, really. And that ties directly into another particularly thorny, rapidly evolving issue: the whole copyright quandary.
Yeah. The training data lawsuits.
Exactly. These AI models, the ones powering coding assistants, they're trained on these massive data sets, billions, maybe trillions of lines of publicly available code scraped from the internet.
GitHub, open source projects, etc.
Right. The huge question is, when an AI learns from all this copyrighted code, is it infringing on those copyrights? Especially if it occasionally spits out snippets that are identical or very close to the original code it trained on.
That seems like a legal minefield.
It is. Multiple lawsuits are currently challenging this. They're contesting the legality of scraping copyrighted code for training data in the first place, and also the issue of verbatim regurgitation, the AI essentially copying homework. It's a really complex legal area. Is code fundamentally different from, say, text or images in the eyes of copyright law? What counts as fair use when an AI ingests and fundamentally transforms billions of lines of code to learn patterns?
And how often does it actually regurgitate stuff verbatim? Is that common?
That's part of the debate. Some argue it's rare and accidental. Others claim it happens enough to be a problem. And what legal precedents are being set right now will be crucial. While some of the initial claims against tools like Copilot have been narrowed or dismissed by courts, others are still ongoing. And the compliance norms, the acceptable practices, are very much still evolving. Plus, as we mentioned, regulations like the EU's AI Act are specifically pushing for much greater transparency and demonstrable copyright compliance for these big AI systems.
So the pressure's on from regulators too.
Significant pressure. It's a massive challenge that lawyers, ethicists, and AI researchers globally are grappling with right now. The outcomes will undoubtedly shape the future of AI development and how we think about intellectual property in this new generative age.
Absolutely, a space to watch closely. And related to hype and reality, when we look at the headlines, especially around these really impressive new tools like Devin, it's incredibly easy to get caught up and mistake a benchmark score for, the real deal.
The benchmark trap.
Yeah. Which brings us to another pervasive myth. Benchmarks equal reality, using Devin as the prime example again. Look, Devin's performance on the SWE-bench benchmark is impressive, no doubt. It shows it can autonomously tackle some complex bug fixes across different projects in that specific test environment.
It's a non-trivial achievement on that benchmark.
For sure. However, we need to treat benchmarks with a critical, almost surgical eye. Benchmark tasks are often, by design, highly contained. They're well-defined, often stripped of the messy, real-world complexities developers deal with every single day.
Sanitized problems.
Exactly. They differ profoundly from the chaotic realities of enterprise backlogs. Think about it. A real-world bug in a big company isn't just about finding one faulty line of code.
Rarely that simple.
Right. It often involves navigating Byzantine infrastructure challenges, dealing with flaky tests that only fail sometimes, trying to decipher deeply intertwined legacy code written by maybe dozens of people over a decade.
Code no one currently working there even wrote.
Exactly. And trying to understand the stakeholder context. Why on earth was this built this way in the first place? That a benchmark just cannot replicate.
The human archaeology of code.
That's a great term for it. Imagine a bug in, say, a 10-year-old microservice. It's failing intermittently, but only under specific high-load conditions. There's zero documentation, and the original developers left the company years ago.
The nightmare scenario.
A benchmark might present a clear-cut bug in a clean, small, well-documented repository. But that real-world scenario demands a developer to talk to colleagues, dig through ancient logs and tickets, explore monitoring dashboards, maybe run experiments, and ultimately make judgment calls based on incomplete, ambiguous information.
Human collaboration and investigation.
Devin, despite its SWE-bench success, would likely struggle massively with that kind of problem. It needs that human context, that interaction. So while leaderboards are useful indicators of potential, maybe progress in specific capabilities.
Treat them as indicators, not guarantees.
Precisely. Do not treat them as guarantees of real-world performance. It's so easy to get swept up in the hype of a flashy demo. But as every experienced developer knows, the real world throws curveballs that neatly packaged benchmarks just don't simulate.
The question isn't just, can it fix a bug?
It's, can it fix my specific messy bug in my specific messy code base with all its weird dependencies and historical baggage? That distinction is absolutely critical for setting realistic expectations and, frankly, for avoiding costly disappointments when deploying these tools.
Precisely. And understanding these critical distinctions, separating the hype from the reality, helps us move towards practical applications and genuine insights. Identifying where AI truly helps today, and importantly where it doesn't, or where it needs significant human guidance.
Okay, so let's get practical. Where does AI really shine right now?
One area where it's particularly strong is in what we call greenfield scaffolding, and also acting as that highly efficient junior partner we talked about.
Greenfield scaffolding. What does that mean in practice?
It means AI tools excel at generating the initial structures, the basic frameworks, for brand new services or projects, starting from scratch, where there's no legacy code, no existing complexity to navigate.
A blank slate.
Exactly. For example, tools like Copilot, especially the newer workspace version, can draft entire API endpoints. They can generate corresponding unit tests for those endpoints. They can even produce basic infrastructure stubs, like, say, the initial configuration files for deploying a new microservice using Kubernetes or Terraform.
And it does this just from a description?
Often, yes.
Yeah.
Directly from a simple high-level issue description or a comment. You might type, create a REST API endpoint for user profile management with JWT authentication and basic CRUD operations. And the AI can generate a surprisingly large chunk of the necessary boilerplate code.
Saving a lot of initial typing.
A lot. This capability was famously validated in that controlled HTTP server task GitHub ran, remember? where developers using Copilot were 55% faster.
Right, the boilerplate advantage.
Exactly. This ability to quickly convert a vague intention into a working sketch, a starting point, it effectively raises the leverage of junior developers. It gives them a powerful assistant to get started. And often, it dramatically improves documentation quality too, just by providing initial well-structured code examples.
So if you're starting fresh on a new project,
AI can be like having that super fast assistant who lays down the basic framework, the scaffolding. It frees you, the human developer, up for the more strategic decisions, the complex logic, the you needed parts of the problem. It lets you iterate much, much faster in those early stages.
okay, so a fantastic boost for new projects. But then inevitably, there are areas where that caution light needs to be flashing brightly, where human oversight isn't just important, it's absolutely indispensable.
It's absolutely critical area.
Like security-sensitive code, for instance. We keep coming back to this.
Because it's that important.
Those replicated studies you mentioned, they show that when developers, even experienced ones, sometimes, or certainly students, accept the AI's initial suggestions for critical functions.
Crypto, auth, input validation.
Yeah, the really sensitive stuff.
Yeah.
There's a significantly higher rate of vulnerabilities found in that generated code compared to code written carefully by humans or code that's been rigorously reviewed.
The risk is measurably higher.
And we're not just talking about minor bugs here. These are potential open doors for attackers. SQL injection, cross-site scripting, insecure password storage, the works.
Real-world attack vectors.
And this risk persists unless humans apply really rigorous threat modeling, actively thinking like an attacker, asking, how could this code be broken? And consistently use advanced security scanners to audit the AI's output. You can't just trust it.
Blind trust is dangerous here. If a junior dev blindly accepts an AI-generated function for handling user passwords, maybe it looks okay, but it doesn't use proper salting or uses a weak hashing algorithm. The consequences could be a massive data breach down the line. Human verification is essential.
Non-negotiable. And the same kind of caution applies to those legacy bug hunts, right? Digging through old, complex code.
Definitely. Mature code repositories, maybe with brittle tests that break easily, complex interdependencies between modules, often sparse or just plain wrong documentation. Development teams report very mixed results trying to use AI effectively there.
Because the AI lacks the deep context.
Precisely. These environments are the polar opposite of greenfield. Often, trying to integrate AI into these deeply entrenched, messy systems can actually lead to increased review overhead.
More work, not less.
Sometimes, yes. It echoes those measured slowdowns for experts we discussed from the Amateur study. The AI might suggest a fix for one bug, but because it doesn't understand the intricate web of dependencies built up over years, its fix might break 5 other things silently.
Causing more debugging downstream.
Exactly. Leading to more time spent debugging, reviewing, and correcting the AI's well-intentioned but ultimately flawed suggestions. So the takeaway here is, for the really sensitive stuff, the security-critical parts, or for untangling years of inherited complex code, AI is much more like a junior partner that needs constant, careful guidance and correction.
Not a lead engineer you can just set loose and trust.
Absolutely not. The human needs to be actively involved in threat modeling, rigorous verification, understanding that tangled web of dependencies and historical context. And these observations, these different experiences, they underscore the diverse expert opinions and theories that are currently shaping how we understand AI in coding. It reflects the complexity of the technology itself. It's not just one thing.
Right, there isn't one single consensus view.
Not entirely, though there are prevailing themes. The main one, the most mainstream view, is what we can call the augmentation thesis.
Okay, augmentation, like making humans better.
Exactly. Proponents here think GitHub's own research team. Many practitioners we talk to on the ground, they frame AI primarily as a powerful force multiplier.
Amplifying developer efforts.
Right. They believe it dramatically accelerates the routine tasks, significantly improves documentation by generating clear code examples, and, importantly, profoundly raises developer happiness and reduces burnout by offloading the mundane, repetitive work.
Focusing on the positive.
In this view, humans retain that essential ownership of the high-level stuff. design, architecture, critical review, ethical considerations. AI acts as that super efficient assistant, freeing humans for higher value activities. The future is human ingenuity amplified by AI.
That sounds pretty optimistic. What are the other views?
Well, then you have what we might call skeptical operationalism.
Skeptical operationalism. Okay.
This view is championed more by researchers like those at METR and others focusing on empirical measurement. They offer a crucial note of caution. They emphasize the integration costs.
The hidden costs of using AI.
Exactly. Things like the time spent carefully crafting prompts, the effort of thorough verification, setting up extensive context so the AI even understands the specific project, the constant need to double-check its work. They argue these costs can actually negate or sometimes even reverse the supposed productivity gains.
Especially for experienced engineers.
Particularly for seasoned engineers working on code bases they already know extremely well.
Yeah.
It's that cost-benefit analysis. Again, it doesn't always tip in AI's favor for every task or every developer. The time saved on generation might just be eaten up by the time spent on correction and verification, especially if the AI isn't deeply embedded and aware of the team's specific context and standards.
So a more cautious measure everything approach.
Precisely. And finally, there's regulatory pragmatism.
Driven by the governments.
Largely, yes. Think EU policymakers and increasingly other governments worldwide. Their core argument is that things like transparency, robust copyright controls, clearer accountability structures, these are absolutely non-negotiable prerequisites for the safe, fair, and trustworthy deployment of any powerful general-purpose AI, and that definitely includes coding tools.
That's setting the ground rules for society.
Exactly. This perspective emphasizes the need for societal guardrails, ensuring that the incredibly rapid pace of technological innovation doesn't outstrip our ability to manage its risks, prevent harm, and uphold fundamental rights like privacy and fairness.
So 3 different lenses.
Yeah, you're seeing the same technology viewed through different but arguably equally valid lenses. From the optimistic, powerful assistant view to the cautious cost-benefit analysis to the ethical and societal necessity of strong governance. All of them contribute to a more complete, nuanced understanding of this really complex, evolving landscape.
Okay, so with all these insights, these different perspectives, the history, the myths, what's a practical playbook? If I'm a developer or leading a team, how do we navigate AI and coding? Effectively, responsibly, ethically, how do we actually maximize the benefits while mitigating those very real risks?
That's the critical question. How do we put this into practice?
First, and this seems fundamental based on our discussion, we need to clearly define and maintain the human source of truth.
What do you mean by source of truth here?
I mean keeping your core specifications. Your architectural decision records ADRs, and your acceptance tests as the absolute, unassailable, authoritative blueprint for your software.
The canonical definition of what the software should be and why?
Exactly. For those maybe unfamiliar, ADRs aren't just dusty documents. They capture the why behind significant architectural choices. They explain the problem faced, the options considered, the trade-offs, and the final decision made. They provide that crucial context and rationale that AI currently just can't infer or invent reliably.
The human reason.
Right. So the guideline is, use AI primarily for drafting, for exploration, for generating initial code, for speeding up implementation based on clear instructions, but never for making those final high-level decisions about architecture or core requirements.
AI suggests, human decides.
Precisely. Think of AI as that very capable, very eager-to-please intern again. You give it a clear task based on your established plan, it drafts something impressive, maybe very quickly. But you, the human developer or architect, are still the ones signing off. You ensure it aligns precisely with the overall vision, the detailed requirements, the architectural principles you've already defined in your specs and ADRs.
Retaining strategic control.
It's absolutely paramount. It's about leveraging AI speed for execution while ensuring human intelligence and judgment remain firmly in control of the strategy, the design, the what, and the why.
That makes perfect sense. And building directly on that, security has to be woven in from the absolute beginning. It cannot be an afterthought.
Right, not just bolted on at the end.
Which brings us to a practical approach. Secure by prompt plus scan.
Okay, break that down. Secure by prompt.
This means proactively training your developers, making it part of the culture, to explicitly ask for secure patterns directly in their prompts when interacting with the AI.
Giving the AI security instructions.
Exactly. So instead of just saying, generate a function to compare these two strings, you'd be more specific. Generate a constant time string comparison function to prevent timing attacks. Or instead of write code to query the database, you'd say, generate code using prepared statements for this database query to mitigate SQL injection risks.
So you're guiding the AI towards safer outputs from the start.
You're essentially teaching it or reminding it to prioritize security in its suggestions for that specific context, guiding its generation.
Okay, that's the secure by prompt part. What about plus scan?
Then, crucially, you absolutely must integrate automated security tools into every stage of your development workflow. This isn't optional anymore.
All kinds of tools.
We're talking static application security testing SaaS tools. They analyze your source code for vulnerabilities without actually running it. Then, dynamic application security testing DAST tools, which test your application while it is running, looking for flaws from the outside in, and also automated code scanning autofix tools, which can often identify common vulnerabilities and suggest or even automatically apply the fixes.
So multiple layers of automated checking.
Exactly. These tools act as essential safety nets. They rigorously verify the AI's output, and frankly, human-written code too. They catch things humans might miss. So the combination is key. Prompt for security, guide the AI well, but then use robust automated scanning to verify. Security has to be built in and continuously checked.
Okay, so we've prompted securely, we've scanned the code, but we still need human review, right?
Yeah.
You emphasize that. How do we do that review effectively for AI-generated code?
Yes, human review remains vital, and we suggest adopting a structured two-pass review strategy.
2 passes. Okay, what's the first pass?
The first pass should focus entirely on intent. Does the AI-generated code actually solve the right problem? Does it align with the initial intent expressed in the ticket or the spec? Does it fit the overall design? This is about high-level correctness, about the purpose of the code.
So before looking at the details, you ask, is this even what we wanted to build?
Exactly. For example, if you ask the AI to build a user registration feature, this first pass confirms. Yes, it registers users, it has the expected fields, username, password, email. It seems to fulfill the basic requirement.
Got it. Then what's the second pass?
Only after you've confirmed the intent is correct do you proceed to the second pass. This pass focuses purely on implementation. This is where you meticulously review the specific code details.
The nitty-gritty.
Right. You're looking for performance issues, memory efficiency, adherence to team coding standards and style guides, and crucially, digging deep for potential security vulnerabilities that the scanners might have missed or that are context dependent.
So asking, is this built well? Is it efficient? Is it secure?
Precisely. In our user registration example, the second pass would scrutinize. How are passwords being hashed? Is it using a strong, modern algorithm? Are salts being used correctly? Is all user input being properly validated and sanitized to prevent injection attacks? Are the database interactions efficient? Are there potential race conditions?
Like editing a document, first check the message, then proofread the grammar.
That's a perfect analogy. First, check if the core message, the intent, is right. Then proofread for the details, the grammar, the style, the accuracy, the security. Both steps are absolutely crucial for ensuring high quality, preventing downstream issues, and really leveraging AI speed without sacrificing that essential human-level judgment and quality control. And thinking about quality and process in a world where, as we've discussed, provenance and accountability are becoming increasingly critical.
Especially with regulations like the EU AI Act coming.
Exactly. We really need to consider practices for tracking AI edits. We need transparency and auditability for code generated or modified with AI assistance.
So knowing where AI touched the code.
Yes. This means implementing clear, consistent practices to label AI-assisted pull requests, PARs, or maybe even specific code changes within your version control system, like Git.
How would that work? Just a tag?
It could be as simple as a standardized tag in the commit message, or PR title, like AI-assisted or Copilot drafted. Or it might involve more structured metadata, perhaps indicating which AI tool was used, maybe even linking back to the prompt or the issue that triggered the generation.
Okay, so labeling is step one. What else?
Then you should probably institute a process to regularly sample these AI-assisted contributions for audit purposes.
Audit them. Why?
It's not necessarily about mistrust, though it helps with quality control. It's more about establishing a clear chain of custody for your codebase. It helps you understand how much of your code is being influenced by AI, identify potential systemic issues or recurring error patterns from the AI, and demonstrate due diligence.
This helps with compliance.
Absolutely. This kind of practice directly helps meet those emerging transparency expectations, particularly those being driven by regulations like the EU AI Act, which will likely require greater clarity on how GPI systems are being used, especially in critical or high-risk applications.
So it's just good governance.
It's good governance, good risk management, and likely soon a regulatory necessity in some regions. It allows you to explain, trace, and potentially justify the origins of your code base, which could be absolutely vital in a security incident investigation, a compliance audit, or even a legal dispute down the line.
Makes total sense. So all these changes we've talked about, new tools, new prompting skills, new review processes, new tracking, new regulations, it all points to one thing. Developers themselves need to actively upskill for this new era, this new craft of coding.
The skill set is definitely evolving.
The job isn't going away, as you said, but it's profoundly changing. And your skills need to evolve right along with it. This involves developing, for instance, a new kind of literacy, AI failure modes literacy.
Understanding how the AI messes up.
Yeah. You need to understand where AI tends to go wrong. Where does it create suboptimal solutions? Where does it introduce hidden risks or biases? You need to know its common blind spots, its typical hallucinations, the types of complex problems it consistently struggles with. Becoming familiar with how it fails makes you better at reviewing its output.
Knowing the tool's limitations is key.
Absolutely. And mastering effective prompt engineering is also just crucial now. It's not a nice to have. It's becoming core to guiding tools like Copilot or Workspace to get the best, most relevant, most secure outputs possible. It's like learning a new communication skill, a way to unlock the AI's potential effectively.
Talking to the machine well.
Exactly. And finally, integrating approaches like test-first development with AI assistance seems really powerful. Write the tests first to define the expected behavior, then use the AI to generate code that passes those tests. Creates this really strong validation loop.
Using tests as the specification for the AI.
Right, so the bottom line is the most successful developers in this new era will be those who adapt proactively. They'll become experts not just in writing code, but in orchestrating AI, understanding its strengths, its weaknesses, knowing how to steer it effectively, how to verify its work rigorously, and ultimately how to leverage it to enhance their own unique human creativity, problem-solving skills, and critical thinking.
So, as we've explored throughout this whole deep dive, that narrative, the simple one about AI just replacing coders outright, it's far too simplistic. It misses the nuance completely.
Yeah, the reality is much more interesting.
The truth, as we're seeing it unfold, is we're witnessing a profound and frankly pretty exciting recomposition of the developer's role. Tasks are shifting away from mere typing, from rote execution, towards deeper thinking, towards strategic problem decomposition, architectural vision, and that absolutely vital layer of critical human-centric review and validation. It really is about leveraging AI as an incredibly powerful tool to enhance human capabilities, not to diminish or replace them.
Indeed. So the enduring question really isn't, will AI replace coders anymore, is it?
I don't think so. Not the right question.
The real question seems to be, which parts of coding, which tasks will we thoughtfully, deliberately entrust to machines? And then, crucially, how will we redesign the human work around them to create even greater value, better software, maybe even more fulfilling jobs?
How do we build the optimal human AI team?
Exactly. It's about how we create the most effective, the most efficient, and also the most ethical human-AI collaborations, leveraging the unique strengths of both to build whatever comes next in software.
And the next frontier you see looking even further ahead is probably truly trustworthy autonomy. Building AI systems that can not only plan and execute, but also test themselves rigorously and explain their reasoning well enough that they could operate with a higher degree of independence.
But safely.
But always, always within clear guardrails that society finds acceptable, and always with mechanisms for transparent human oversight and intervention. That's a long-term research goal. Until then, and likely even after, the winning teams, the most innovative organizations, will be those who learn to manage AI effectively, not as some magic overlords, not as a silver bullet, but as a powerful, often helpful, but definitely fallible and ultimately accountable teammate. So for you, our listener, the fundamental question to perhaps ponder as you go about your day is this. In your own work, in your own organization, what responsibilities are you willing, and is it wise, to empower AI with? And just as importantly, where will you draw your critical lines? Where does human judgment, human intuition, human responsibility absolutely need to remain in control?
That decision, that calibration.
That's the decision facing every developer, every team leader, every organization navigating this incredible technological shift right now. Where do you draw the line?